Here we go. Lesson 4-1, page 113. We're not going to be doing the entire lesson today. This is a really long one. We're going to break this lesson into 2 days, but we are going to do a good portion of it today. And then the very end of it is like a whole different skill, so we'll save that for tomorrow. But we've been doing a lot with fractions, right? And if you remember, we added and subtracted fractions first, and then we went to adding and subtracting decimals. And then we did multiplying and dividing with fractions. So what do you think we're heading into now? Shout it out.
Dividing decimals.
Multiplying and dividing with decimals, yep. So Unit 4 in math, multiply multi-digit numbers using models and different methods. Last year in 4th grade, you guys learned lots of different ways to multiply. We're going to review all of those ways with you. We'll also do multiplying with whole numbers and decimal numbers. Some other goals are to solve real-world problems, understand patterns, use estimation, and learning about exponents. That's the second part of the lesson that we'll do tomorrow. Last year, you might remember learning about like the place value sections method for multiplying, expanded form for multiplying, and then the good old shortcut method, or turtle head. We call it turtle head too. Okay, so we're going to review all of those different methods for multiplying. First, we're just going to talk about some general skills when it comes to multiplying. And we're going to talk about shifting of whole numbers. So, does somebody want to read this first situation to me? Morgan, thank you. Make sure you stand up for us.
Jordan earns $243 a week. The money is shown at the right. Answer the questions about how much he will earn over time.
Good. So you can see they've got the bills underneath. So $243, right? 3 $1 bills, 4 $10 bills, and 2, they call them Benjamins, $200 bills. Okay? $243. So we're going to use that as the basis for the next couple pages here in our book. First thing we're going to look at is when you multiply by 10, the digits shift one place to the left. If I am multiplying 243 times 10, right, I'm going to put my 2 was there, my 4 was there, my 3 was there. Do you see how each one of these digits shifts one place to the left? Because I multiplied by 10. And then what do I fill in that ones place?
A zero.
A 0. The 0 from my 10, I had 1 0 in 10, so that 1 0 gets put in the ones place. So after 10 weeks, how much will Jordan have earned, everybody?
2,430.
You got it. It's right there for you, right? You didn't even have to do anything. 2,430. Oh, here's another little lesson that kids nowadays need to learn. When you're writing about money, the dollar sign comes first. The dollar sign doesn't come after the 0. Please make sure you're joining me and filling it in at the same time. Please make sure you're joining me and filling it in at the same time. What happens to each $1 bill? So our 3 $1 bills, when we multiplied them by 10, what happened to each one of those $1 bills? Corey?
It turned into a $10 bill.
Yeah, they got 10 times larger, right? They became 10 times larger. What happens to each other bill when they're multiplied by 10? Gabby?
Turns into hundreds.
Well, each other bill. What happened to my 4s? What happened to my 4 10s? What happened to my 2 hundreds?
The 200 turned into 2,000.
Okay. So each one of those also became 10 times larger, didn't they? My 10s became hundreds, and my hundreds became thousands when I multiplied them each by 10. So when you multiply by 10, does each digit shift to the right or to the left? Does each digit shift to the right or to the left? Landon?
It shifts to the left so it has a spot for the 0 to go.
Yep, it shifts to the left because they get 10 times larger, right? They're getting 10 times larger, so they're shifting to the left. If they shifted to the right, they wouldn't be getting larger, they'd be getting smaller. But when we're multiplying by 10, we're multiplying by something greater than 1. Remember what we talked about with fractions? Multiplying by something greater than 1, so they're going to get larger. How many places do they shift when we multiply by 10? Show me on your fingers. How many places do they shift? One place. How many zeros are there in 10? 1. 10 times is one place. Each place value position makes it shift one time. Make sure you have filled all of these in, please.
I'm having a really hard time with this.
Okay, right now I just need you following along and filling them in as we go. We're going to be seeing a pattern here as we move through this. Just a minute to finish copying these down. Okay. Check your questions because yours got off somewhere. See my number 5, the answer is 1. Go ahead and fill that last one in too. All right. Let's look at the next page. What do you think we're going to do on the next page? No, we're not going to jump to division yet. So we just did after 10 weeks. Look what we have now. Now we have 100 weeks. Again, I'm going to write down my 243 because that's what we started with, right? Week 1 was 243. After 100 weeks, how much has Jordan earned? It tells you right here, right? This amount. How much has she earned? Shout it out. $24,300. Put that dollar sign in the front, and I loved that I didn't hear anybody say and. Because and means we've got a decimal point in there. $24,300. What happens to each $1 bill when it's multiplied by 100? Look, remember, here was my 3 before. Now I'm coming over, boop, boop. I am all the way over to here. What happened to each to each $1 bill? Ashlyn? Okay. How many times larger did it get? Ashlyn? Not 1 time larger. So it's shifting 2 spaces. It used to be a 1, now it's in the hundreds place. So it got 100 times larger. Right? Because I had 3 before, now I have 300. 3 times 100 gets me to 300. They get each $1 bill becomes 100 times larger. What happens to each digit when it's multiplied by 100? What happens to my tens? What happens to my hundreds, Zach?
It moves to the left.
They move to the left. How many times larger are they getting?
100.
They're getting 100 times larger. Okay. Need to make sure we're standing up, everybody, when we answer questions. When you multiply by 100, does each digit shift to the left or to the right? So watch. My 3 was here. It's shifting over this way. Is this direction the left or the right? Everybody.
Left.
The left. They're shifting to the left because when we shift to the left, we get larger.
I don't know my left or right.
I can teach you a quick trick. Do this with your hands. Okay? Which hand makes an L that's going the right direction? This one, right? This is my correct L. This is a backwards L. So this L right here tells me this is my left hand. So this is the left direction.
Or you can just tell
So
if you're
since
righty
they're
or lefty.
shifting this way, they're going to the left. Yep, if you're a righty or a lefty too, if I know I write with this hand, then this must be my left hand. No, I'm not talking to you. Okay? If I'm a righty, I know that the opposite is my left.
Okay, I'm probably gonna forget that because I say that to me a lot.
That's all right. Just something else to work on remembering, right?
Yep.
How many places do they shift to the left? So we started here. We went from Berber to Berber. How many places was that, everybody?
2.
2 places. How many zeros are in 100?
2.
2. Thank you, Corey. I got you on that one. I saw you stand. There's 2 zeros. When we multiply by 100, we shift 2 places, 2 zeros, 2 places to the left. Now we've been doing this job for a long time, right? Because 100 weeks is just shy of 2 years. But now we're at 1,000 weeks. 1,000 weeks. I'm going to put my 243 right up there again so I can kind of see it. After 1,000 weeks, how much money will I have earned? Everybody.
$243,000.
$243,000. Don't throw the word "and" in there. $243,000. Dollar sign comes to the front. What happens to each $1 bill when it's multiplied by 1,000? So it starts as a 1. It starts as $3. Now we have $3,000. Morgan, stand up.
It gets 1,000 times larger.
They become 1,000 times larger. And what happens to every other bill? Everybody.
1,000 times more.
Yep, you got it. They all become 1,000 times larger. Every bill, if I'm multiplying by 1,000, every place value is going to become 1,000 times larger. So my 3 started here. Look at it, shifted, bump, 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 all the way over here, going this direction. When you multiply by 1,000, does each digit shift to the right or the left? Everybody.
Left.
How many places?
3.
3. How many zeros are in 1,000? 3. 3 zeros. I shifted 3 places.
It's kind of like the wave. Everybody's standing on.
Okay. Let's take a look at this next page. We're going to see the shift in motion. Please make sure you're following along with me and not on something that you're not supposed to be on. Question, Jaslyn?
This person, Jordan, is getting really, really comfortable.
He's making some good money. Yep, making some good money.
$243,000.
All right. See the shift in motion. Isabel earns $325 a week. 3 students can show how the digits shift at the board when we multiply her earnings. So suppose Isabel works for 10 weeks. Find her earnings. So we start with the $325 times 10. What direction is this 325 going to shift? Everybody, what direction? To the left. How many places? 1 place. So we fill in that far left place with the 1 0 because we've got 1 0 and 10. And then every other digit we just fill in. And that shows our numbers have shifted to the left 1 place. So it shifts. How many places did we say? 1 place. Which direction? Left. It becomes 10 times greater.
I have a question.
Yes.
Is it okay if you take
take this home, but make sure you bring it back each day. All right, suppose she works for 100 weeks. My $325 times 100, look, I've got a 0 here and a 0 here because 100 has 2 zeros. Every other digit shifted on over. How many times?
Dos.
2. Dos, si, senor. How many places to the what direction?
Left.
You're not going to say that in Spanish?
Huh? No, I don't know.
Izquierda. Izquierda. To the left. 2 places to the left because it comes 100. 2 zeros. Greater than 1. We're shifting to the left. 2 places. Okay. Suppose she works for 1,000 weeks. Find her earnings. $325 times 1,000. How many zeros is that? 3. How many places am I shifting? 3. Which direction? Left. To the left because it's getting larger. Here's where we test it out. Here is where we test it out. And do these in our heads. We shouldn't have to write anything down to solve these problems. 567 times 10. First thing I'm going to write down is my 0, right? Because I have 1 0 there, so I know that in my ones place, I'm going to have a 0. That 567 is the next part that I write down. 5,670. Oh. Let's look at 20. I have 38 times 1,000. First thing I'm going to write down is what? 3 zeros. 0, 0, 0. What comes next?
38.
My 38. Did that follow the right pattern? When I multiply by 1,000, did my 38 shift 3 times to the left? Yes, it did. Please make sure you put your commas in there and put them in the correct place. Right? After 3 digits, you have a comma. Okay? It separates what they call the periods in the numbers. Okay? All right. 912 times 100. What am I going to put down first? 2 zeros. And then I write in 912. Throw my comma in there between the 1 and the 2. Ooh, the next one looks a little trickier. It's not? Excellent. What's the first thing I write down? A 0. What do I write down next?
700.
Oh, my whole 700 gets written down. So what does that give me? 7,000. You guys are so smart. Good. But you figured it out. That's what's important. All right, so the Skyway Express train travels about 800 miles a day. That's 1 day. How far will it travel in 10 days? How am I going to solve this problem? What am I ever going to do? Corey, thank you for raising your hand.
Add a 0 and then add 100.
Okay, first, but I see where you're going, but why am I doing that? What's the mathematical equation?
You move everything to the left, so
But what would my equation be to solve this problem?
it would be 800 times 10.
800 times 10. Good. And so now go ahead and tell me how to do it.
So you would, since everything moves to the left, you would put your 0 down first, and then you would add 800.
And then I would put my 800 in there. Yep. And it's 8,000 miles, right? Don't forget your labels so that way we don't think we're talking cookies here because that's a lot of cookies.
What's good cookies?
Well, hopefully they're good cookies. There are cookies that are not good. Since there are 30 days in April, about how far will a train travel during the month of April?
Oh, no, I'm not good at something. How long is April? Yeah. 31 days or 20? 31 days and 800?
Okay, there's 30 days in April.
Oh, it says.
This one's getting a little tricky. Go ahead, talk to us about it, Mason. Stand up and talk to us about it.
So what I did, I knew that 8 times 4 equals, or 8 times 30 equals 24. So then I just added the 3 zeros and I got 24,000.
So you said you were going to do 800 times 30, right? Okay. Because it goes 800 miles in one day, but we have 30 days. Mason, notice that on all of these, look, it's like 8 times 1 stays an 8. 912 times 1 stays 912. But if we did 8 times 3, that gives us 24. And then we have 1, 2, 3 zeros to throw on the end. 24,000 miles. Awesome. Good job. Questions? Hey, no, I didn't tell you guys to put anything away yet. I just asked if you had questions so far. All right. So, here comes the tricky part. Here comes the tricky part. We've been doing shifts with whole numbers, haven't we? Multiplying by 10, 100, 1,000. What if it costs, and you guys are going to be like, you can't say money like that. Because look, they went all the way to the thousands place. Tens, hundreds, thousands. 412 thousandths of a cent.
What?
The only place, right, the only place I've ever really seen money like this is at a gas station. A lot of times at gas stations, they'll go to this thousandths place in the money. Don't let that fool you up though, okay? For a factory to make a red phantom marble, the money is shown here. So 4 dimes, 1 penny, and 2/10 of a penny. Okay? So read each question about the cost of making different numbers of red phantom marbles. So let me put my original in here. I'm going to put my decimal up there. My 4, 1, 2. How much does it cost to make 10 red phantom marbles? That's just the number they already wrote in there for you. How much does it cost?
$4.
Shout it out.
$4.12.
It cost $4.12. Yes, that and gets our decimal in there. $4, we've got our $4 bills, our dime, and our 2 pennies. Because now we're making 10 of them, right? This was the cost for just 1, but now we're doing 10. So just like before, what happens to each coin when it's multiplied by 10? 10 times larger. 10 times larger. If it was in the thousandths place, it becomes the hundredths place. If it was in the hundredths place, it moves to the 10th place. If it was in the 10th place, it goes to the ones place. Each time you shift over one place value position, you're getting 10 times larger. What happens to each of the other digits? They all get 10 times larger, right? Every digit becomes 10 times larger. So when you question? Landon, I want only Landon to answer this question. When you multiply by 10, does each digit shift to the left or the right? To the left. And Landon, when you multiply by 10, does it shift how many places?
1.
1 place when you're shifting by 10. But now, do you guys notice a difference between this and when we did the other ones?
Yeah.
What's the difference, Zach? What do you see? Stand up for me. What?
It's harder.
It's a little bit harder. It's not super much harder. That's not quite the difference I was looking for. Morgan, do you see my difference?
Because there's a decimal, and you have to say and.
There is a decimal. Yep. That's still not quite the difference. Alex, do you think? No. Corey, do you think you see the difference?
There's thousands.
No. Did you guys notice on the others there was always this digit over here at the end when we multiplied by 10? Do we need to have that 0 there? No, right? At the end of a decimal, we don't have to have that 0. But if it makes you feel more comfortable to write that in to show yourself that everything is moving over one place, that's fine. Okay, that's fine. But I also want you to think about it this way. Look, when I multiplied it by 10, my little decimal point, boop, he just hopped to the other side of the 4. Right? When I multiplied it by 10, that decimal point just hopped over one place on the other side of the 4 to make it larger. Let's see if that can continue with the others. Guess what we're going to do next? We're going to make 100 red phantom marbles.
Why?
Why? Why not?
Yeah, why not?
We now have 100 red phantom marbles. So again, I started with 412 thousandths. Okay. How much does it cost to make 100? Shout it out. $41.20. Yes. What happens to each coin when you multiply by 100? Shout it out.
It's 100 times bigger.
They each get 100 times larger. Each digit also gets 100 times larger. When you multiply by 100, does each digit
Left.
shift to the left or the right? Go.
Left. Left.
When you multiply by 100, does each digit shift? Well, each digit shifts how many places?
2.
2 places. 100, 2 zeros. It's going to shift over 2 places. Now, you might have noticed that this one actually has a 0. Because I can't have money that looks like this, right? Where am I? I put my decimal in the wrong place. 41 and 2. Oh, my goodness. Let's start that over again. Money does not look like this, right? I have to have my 0 on the end for that to be money. But do you see how each digit still shifted over 2 places? Okay. Let's talk about that other thing that we mentioned before. My decimal point started right here. Did my decimal point shift 2 places?
Yes.
Yeah, it went here and then it went here, didn't it? Here, let me write this up here a little bit better so you can see it. It went to here and then it went over to here. So my decimal point is going the opposite direction of my digits, isn't it? My decimal point is going to the right as my digits go to the left. And my decimal point is moving the same number of places as my digits. Let's see if that works for the last one too. How much does it cost to make 1,000 red phantom marbles? Everybody. $412. They have the decimal with the 2 zeros there. What happens to each coin when you multiply it by 1,000? 1,000 times larger. I heard it over there. Each digit becomes 1,000 times larger. What happens to each digit? 1,000 times larger. When you multiply by 1,000, does each digit... Oh, Alex wants to share. Shift to the right or the left, Alex?
Left.
Left. How many places, Alex? How many zeros?
2, 3.
3. So how many places? 3. 3 zeros, 3 places. Let's look at that decimal comparison that we talked about before. I started with this. Oh my goodness. I was thinking 3 places and I wrote a number 3. Do you guys ever do that when you're thinking something and writing and you end up writing what you were thinking, not what you wanted to write? Let's see, does my decimal shift opposite? 3 places to the right. Boop, boop, boop. My decimal's now there, which makes it 412, doesn't it? For 1,000 marbles? That's a lot of marbles. Hope you don't lose your marbles. Thank you for that courtesy laugh. All right. Last page we're going to look at.
What? It's like, last thing. It's 30 minutes.
All right. So we need to look at some patterns in multiplying with zeros, okay? If this is a lot like times tables, right? Where you look at the numbers on the left and the right of each other. Diesel, please stay with us. And I'm sorry, look down the side and across the top, and you meet in the middle and you see what you end up with. So for example, here I have a 3 and a 2, and I come to that box. 3 times 2 is? 6. 2 times 30, I come over to here. 2 times 30, well, I could think of it as like 2 times 3 times 10, right? Because 3 times 10 makes 30. If I multiply my 3 and my 2, I get 6 times 10, which gives me 60. 2 times 300 is like 2 times 3 times 100. If I multiply that 2 and 3, I get a 6 times 100, which gets me to 600. Corey, do you have a question?
No, I found something.
What'd you find?
A pattern. It's multiplying by 10 each time.
Yep.
On each second.
Yep, you got it. Each one gets 10 times larger. So we work our way up to 3,000 times 2,000. Well, 2,000 is like 2 times 1,000. 3,000 is like 3 times 1,000. Take my 2 and my 3 and multiply them together, I get 6. 1,000 times 1,000 is 1,000,000. 6 times 1,000,000 is 6 million. Okay? So it's just showing you a way to break down the multiplication. Although it looks like most of you have already solved 40 to 44 because you are anxious and you want to just keep going. So let's take a look at those. So the key that we're getting from here, heads up. There we go. Multiply your base numbers first. What's 6 times 3? 18. How many zeros am I going to put on there? 1. Again, what's 3 times 6? 18. 0 there, 0 there. I'm going to throw 2 zeros on there. Finish out 42, 43, 44. Probably because you were working when you weren't supposed to be. So I don't know that that's the best thing to shout out. 6 times 3 is still 18. 1, 2, 3 zeros. 1, 2, 3 zeros in my answer. Look at that. 6 times 3 is once again 18. 1, 2, 3, 4 zeros. 1, 2, 3, 4. Oh, I put my comma in too early, didn't I? I put my comma in too early. Just cross out a 0. Yeah, just get rid of a 0. We don't need it. 6 times 3, once again, 18. 1, 2, 3, 4 zeros. So I will warn you guys, there are problems like this on the quick quiz that are more in a pattern. And you guys, often when you take the quick quiz, you stop looking at the numbers and you think, oh, it's just adding a 0, adding a 0, adding a 0. But look, these last two were the exact same answers, weren't they? 600 times 300 is the same as 6,000 times 30. Okay, so don't just add zeros blindly. You got to make sure that you're looking at each one in detail. Question? 41. I did. You're right. Thank you. All right. Oh, because it's blocked. All right. Let's set this aside and take out our homework books. All right. For your homework, please listen. We're on page 75. On page 75, you are just going to do the evens. 2, 4, 6, 8, 10, and so on. On 76, the back side. If you are still confused about some of the fraction things, please make sure you're asking. Fractions are not going away, friends. Fractions are not going away. I know we just tested on fractions on Friday. That doesn't mean that you're never, ever going to see fractions again. On page 76, I want you to also just do the evens. Please just do the evens on both of these. Even if you want to do all, I want you to just do the evens. Ashlyn, question?
On the remembering side, I don't